of problem is actually solved. So now we'll discuss about the flip-flop, basically edge trigger flip-flop. So flip-flops are synchronous bistable device. The output changes state at a specified point on a triggering input called clock. Change state either at the positive edge or at the negative edge. Positive edge means rising edge, negative edge means falling edge of the clock signal. So what does it say? So this is basically our clock signal, like high low, something like that. So if you go from low to high, so this one is called positive edge. If you are going from again low to high, this is your positive edge. But if you're going from high to low, so this transition is called negative edge, same as it's high to low, so this transition is negative edge. So whenever we have a clock and due to this positive edge or negative edge, our state will be changed in the flip-flop. So previous problem can be solved in this flip-flop. So now look at here. So this is couple of diagram for SRD JK trigger flip-flop, and remember this sign, this symbol represents the clock input. So say like here, this is your SR flip-flop, so and this is your clock. So this represents the clock signal, right? This kind of sign, and this is your D flip-flop, this is your JK flip-flops. All of them have clock. But remember, all of them are positive edge clock. That means they will activate at positive edge. And if you look at the bottom part, so they are called negative edge, because if you look at here, this clock is actually here there is a bubble. So that's the difference. That means all of these flip-flop work as negative edge. So now look at the SR flip-flop. So on the triggering edge of the clock pulse, that means it could be positive edge or negative edge. If your S is high, S high means your R low, and S high means set state. R high means reset state. Obviously, in that case your S is low. And if both input low, there will be no change. And if both input high, and this is the invalid state. So this is the basically characteristics table of positive edge triggered SR flip-flop. So if you look at here, so there is no clock, that means there will be no change whatever you have the value of S and R. But when there is a clock, remember this is positive edge clock. If negative edge, it will be downwards sign, and upward sign is for positive edge triggered clock. So if your R is high, that means reset. If your S is high, that means set. And other is zero, like this one zero, this one zero. If both is high, invalid. If both is low, that means no change. X represents don't care here. So our SR flip-flop, it consists of three parts. These are one basic NAND latch, another one is a pulse steering circuit, and the last one is pulse transition detector or edge detector circuit. So the pulse transition detector detects a rising or falling edge and produces a very short duration of spike. So if you look at here, this is your SF flip-flop representation. So this is your latches and latches. This is your pulse detector circuit and steering circuit, and this is your clock. So whenever you have clock, like this is your clock and this is your inverted clock. So if say like it is working at positive edge of clock, so then it will produce a pulse for very short duration of this positive edge. Also, like if it is working at negative edge of clock, it is producing a very short duration of pulse at negative edge. So this is called positive going transition or rising edge. This is also called negative going transition or falling edge. So for your D flip-flop, This is a single input flip-flop, so it is called data. So if you look at here, this is a single input. So when your input D is high, this is called set state. When your D is low, this is called reset state. So basically your Q follows D at the clock edge. Convert SR flip-flop into a D flip-flop. So how you can do it? You just need to add a inverter. So previously, if you consider SR flip-flop similar to this, so that was your S, this was your R, but here if you use this one as a inverter, so that will be inverted here and connected here. Now you have single input instead of double input. So, and also you have the clock as well. Obviously this is positive edge of clock, so this D flip-flop will work as positive edge. So at clock edge, this is positive edge. Obviously when your data is 1, your qt plus 1 is 1, data is 0, qt plus 1 is 0. That means whatever value you have as the input, you are getting it as the output. So 1 means set, 0 means reset. So there have lots of application of D flip-flop. This is one of the application, parallel data transfer. So to transfer logic circuits output X, Y, Z to flip-flop Q1, Q2, Q3 for storage. So what you suggest, this is your combinational logic circuit, right? So they don't have any memory state. So for that we need to use either this kind of flip-flop or register. So you have here X, Y, and Z. So this is transferred to this the first D flip-flop, Y is in a second, and Z in third flip-flop. So these values can be stored in this kind of flip-flop, and this is called parallel data transfer because we are transferring this X and Y, X, Y, and Z parallelly on the clock edge. But remember, this is your negative edge of clock due to this bubble.